Are we live? I think we are. Awesome. Mm, cool. Can I hear myself? Can. Right. Let's go into the stream manager. Um, Stream info. Let's get that. Ring Lua. Okay. I guess that's we'll do today. Um, up, up, up. Yeah, the weirdest thing happened today. Mm, oh well. Hello there. Welcome to the stream. 2 viewers down. That's the record. But yeah, they what we're doing is we're adding Lua support after getting some transform component shenanigans out of the way in between streams. Uh, so yeah, what you see in front of you is the transform component that added uh, with the dirty flag using matrix unions for rotation. Basic stuff. Did have to use some help from AI though. The math kind of went past me, above my pay grade, I guess. Um, but it works. Let me show you. Rebuild here. This test component. I don't really have anything to render right now. I do need to make like a render system, some simple singleton. Could work for now. Afterwards, we can refactor it to use a pattern like a service locator. Um, but yeah, so how I tested this transform component is I set this window position to 0, 0, right? Let me just open that. The test component, I think I maximize this, right? So what happens is now I use the ImGUI stuff to test, I suppose, right? We begin this test component window, testing this transform very inefficiently, mind you, is done by getting the parent, getting the component, the correct one, the transfer component, which should probably be cached inside of the game object class, right? So that we don't always have to do this component call because that does dynamic costing, which does incur runtime costs, performance costs. But all right, I get its world position x, y, implicitly cost that like create, I guess, an I am vec2 struct or class object, I guess. Um, and currently it's set to 0, 0. That's how transform components get created. With their x, y, z, all transforms being default, 0, 0, scale being 1, rotations being 0. Then I added a button, which then adds, I guess, 100 to each of these x, y, and z coordinates. And if we test it out, if I press this, what should happen is this window should move, right? Because transforms move, coordinates change. Hey, let's go. So I suppose going from here to here is a change of 100 by 100, right? Um, so yeah, stuff changes. That's nice. That's the transform components in a nutshell, how I tested it. Um, Next thing, go to CMake lists because we are adding Lua support. Uh, Adding Lua support by using Lua itself, but also it's one neat little library called Sol 2 version 3.0. So I guess Sol 3. Uh, Let me just look it up. Also, let me background. I jumped into this because I immediately got 2 viewers, which is nice. Hello, welcome again. But let me look up the the GitHub repository for this. Sol 2. And go on. Put on some AI generated. Yeah. Music do I want? Yeah, that's nice. Tell me if it's loud though. So, let me show you how my project is structured. Right? So, close all these. The main things that we should worry about: one, the root folder called Park. That's the project's name, by the way. Then we have our root CMake lists file that starts the build process. Then we have source folder for PB files, source files. Then we have our include folder. Then we have extern, which, as you might have guessed, is our external libraries, right? All very nice and well. This is a root, this is a root CMake list file we're looking at right now. What happens? We set our version. We set our version. We say, hey, this project is called Park. We use C++ and our project version. All arbitrary, doesn't really matter at the moment. We use C++20. We make sure that people that build this use that by requiring it. We change the fetch content base directory to the extern folder. Right? Now, why do we do that? If we don't do this, the fetch content base dir is inside of this build folder in a folder called underscore deps, short for dependencies. That's nice and well, but some libraries that I use, especially like in particular GUI, require me to actually fetch headers and whatever from the directory that gets from the repository, let's put it that way. Doing that by going into the steps folder and it just rubbed me the wrong way. Let me put it that way. It's not nice. It's kind of hidden away in between all of the CMake cache and whatever generated things are in the build folder. It's nicer to have libraries that you actually use close to the source files. Let me put it like that. That's what happens here. And if you don't know, fetch content is a package that you can use in CMake that allows you to fetch content from the internet, from GitHub in particular. But okay. Afterwards, we set our output directory, the binary dir bin, this folder. So this gives us our exe, right, with all of our necessary, I suppose, DLLs and other files for the exe. Yeah. For the root CMake, go into the external folder. Right? Here is where we fetch content calls. Hey, I want to install this package. I want to make it available. I want to, I don't know, you tell me. Yeah, so in here, our project uses SDL3, newest version that's released. Then we get imgui, that's the window, like immediate mode GUI, right? Really popular in game dev and related circles. And what we do is we get the docking branch. The docking branch, very interesting, allows us to dock these windows inside of the main SDL, like OS window that we get, which will be useful later on when we actually do some UI, the immediate mode UI, if you want to call it that. Because now that we have our transform component, what we'll have is we can now parent game object to other game object. And parenting gives us the ability, I feel like my music is very loud. Parenting gives us the ability to create a scene graph, right? Creating a scene graph makes sure, well, what am I saying? I'm just rambling here. We want to see how the scene graph looks. The best way to do it is with a hierarchy. And how will you display that hierarchy? You make a window, and then I guess you show the names of all the game objects that you have in your scene, and you create a tree view, right? But yeah, if it's not clear, you will get it when you see it, I guess. But yeah, as I said, here, this is what's happening with imgui. We have to take some source files of imgui and compile them along with our own source files. These 1, 2, 3, 4, 5, these 5 are just imgui base, like the core, I guess, of imgui. And then we have 2 that we need from the backends, right? One for our windower, like window management library, SDL3 for us, and the other one for the renderer, right? Which currently also is SDL3, but this is subject to change. SDL3 gives you this renderer because, well, you'd rather have one than not, so that you can actually see something on the window that SDL creates. But it is not as powerful or feature rich as, say, something like OpenGL or Vulkan or Metal or DirectX, right? That's why this is subject to change. Needs to change. If we ever want to do something that's a bit more than rendering lines and just basic sprites and images, right? Um, Also here, this is what we do is include directories, right? So that our code can actually include MGUI so necessary. And here we have GLM, and that's the OpenGL math library. GLM. That's the thing that gives you that gives you structs and classes for matrices, for quaternions, for vectors, all math related stuff, so that you don't really have to go and create your own implementations of these. Yeah, today we will add Lua to this extern make list. Now we'll also add Sol. We'll include these in our project. And yeah, we'll try and get an object to, I guess, move by parsing Lua, a Lua function. So the aim is, well, we will create this interface, I guess, for scriptable stuff, right? So in Lua, you'll have, for example, functions. Let's say you'll have an update function, for example, right? And the contents of the update function will get called by our engine when updating given game object, right? So our game object probably is going to store, I guess, a script component, something like that, right? A Lua component, or it'll, I guess, directly store a Lua script. Not sure, but maybe we could just have I guess, yeah, you'd have a Lua component. Oh, yeah, no, because all right, how do I explain this? We have to have a way to link a Lua script to a certain game object. The easiest way of doing that is making a component that stores the Lua script, right? And when it calls its update, its render, its MGUI render functions, it needs to, I guess, delegate that call to Lua virtual machine to parse the same, like the same functions, but then in Lua, right? This is nice. This can be done. Not that hard. But this also means that a game object can only have one Lua script, right? The reason it can only have one Lua script is because we only allow for a single instance of a component to live on any given game object. So you can't have two Lua components with two different scripts on a game object. And yeah, that's an issue. What we could do is, I guess, add nodal list that stores Lua scripts on the game object, right? And then inside of the game object's, I guess, update function, I guess the update function will update all of the native components first, and afterwards it'll go over and update Lua components, the Lua scripts, right? Yeah, I think that's a good way to do it. But we will see. I'm just reading the Sol GitHub README now, just so I can see how we have add this to our project. Documentation, quick and dirty documentation. Sol is header only. We don't need to compile anything. However, Lua must be compiled and available. Let's go into the getting started, right? Okay. So I need a distribution of Lua. We'll probably use the vanilla one. Right. What I can do is probably create a new private window. This in here, right? Can I do this? Yes, I can. Let's add and change. Let's form and reset it. And for some reason, it's yeah. Okay. Hello. So we're on the getting started guide, right? This gives us the necessary information to get started. So it only wraps the API that comes with it, yes, so you can pick whatever distribution you like for your application. Awesome. There are lots, but the two popular ones are Vanilla Lua, yes, and Speedy Lua just in time. We recommend Vanilla Lua if you're getting started, Lua just in time, Lua JIT if you need speed, again, or interface also doesn't change. Cool. If you need help getting or building Lua, check out the Lua page on getting started. That is going to be necessary. Note that for Visual Studio, one can simply download sources, include all Lua library files in the project, and build for debug release. Just make sure to adjust the project property page to build as a static library. Okay. After that, make sure you grab either the single header file release or just perform a clone of the GitHub repository here and set your include paths up so that you can get at sol.hpp somehow. Ooh. Note that we also have the latest version of the single header file with all dependencies included kept in the repository as well. We recommend the single header file release. It's easier to move around. Okay. You can also clone submodule the repository and then point at the single sol/sol.hpp on your include files path. Clone with that. Alright. When you're ready, try compiling this. Sure. We should look at Lua. We don't even have Lua. Right, yes, true. No. Okay, installing, building from source, help, embedding. We need to embed Lua into your C or C++ program. You'll need the Lua headers to compile your program and a Lua library to link. If you're getting a ready-made Lua package for your platform, you'll probably need the development package as well. Otherwise, just download Lua. Let's search for Lua plus Speak. Dun, dun, dun. Here. Lua and CMake. Cool, let's read about this. What does it say? Some learning materials recommend integrate Lua into your project by manually download the code. Many people use CMake to manage most of compiling projects. Yes, so I wanted CMake to pull the repos and install temporary files. Yes. It took me a while to work out exactly how, but I made a small CMake list .txt file that downloads Lua into a build directory for where you can call functions without leaving the entire code base behind at your repo. I used Lua to select the build type and CMake to see what this is all about. Yes, okay. With external project. Okay. Okay. It gets that. Alright. So it's gonna make generic and source download objects. Alright. You know what? Another thing that we could do is not that as this example, right? Want to add Lua to my CV project using content. Okay. Reject non. Yes. Okay. Cool. Yes. Yes. Make available. Add executable. Is it this simple? Do we think it's simple? Tags v5.4. Okay. Try it out. Right? What? Let's copy that. Get it here, and it was v5.4.7. Right, that's the tag we want. Exactly. And then we make it available. This is not going to work. Oh, it might. Lua has been retrieved. And build files have been written. Alright, cool. Next step is probably going into here, right? Then we have Lua. Will this work? Cannot be generated correctly. Uh-oh. The target was not found. See, that's the issue. Let's see what ChatGPT said. Target link libraries, private Lua. Target link libraries, private, just Lua? I don't know. I guess. Huh. Can we access type include Lua? Not seeing anything Lua related, which is Lua.hpp should have been found. Yeah. Seems like I'm missing something. Target link libraries, right? Target link library, pivot SDLZL, and we have Lua. Fetch content declare, grep git tag, available, Lua, so here it is. Lua.a need, right? Is there an include? There is no. Yeah. Can't seem to find okay. And then I guess what did this Lua sorcerer? Let's see. Lua sorcerer. Does it work? Go to main. Try to include. Oh, include. No. Dang it. That's not nice. What issue then? Should be including this, right? So all of these should be normally available to us. Directories, as executable, link libraries. Yeah, should all be fine normally. Go back. Right. Here. Lua source there. go back to the this. Yeah. Okay. Maybe if I build. Build files have been written. Build. Try and build at least. Cannot open file lua.lib. Why do you even try that? Yeah. I feel like we're doing something wrong. Yeah, fetch the content, right? Lua isn't really a library, so maybe doing this. Trying stuff out right now. Yes, right, and then if I go F7, let build. Include lua.py. Really? No? Cannot open include file. That's an issue. Why does it not give us access to Lua source directory though? That's the issue, right? I want to at least be able to be like, I don't care if it doesn't build yet, right? What does this actually contain? Okay, message called with incorrect number of arguments. What do you mean? Message text. Oh, yes. Try this. Okay, that's an empty string, probably. Right? There. This. Yeah. Okay, that's not nice. Why? CMake, fetch content, source. Make available. I do call that, right? Fetch content, make available, Lua. Yeah. Um. That's actually kind of weird. Hmm. This seems fine. What if try something like this? Reset the Lua includers. Lua Lua directory and make it parent scope. And then I can take this. Try to have something like that happen. Huh? Okay, that's weird. Hmm. Okay. That's actually pretty concerning. Empty. It's like weird. Is it like because I'm moving it through its CMake files? Feels like a scope problem. Yeah, oh well. I suppose I will use Lua includers, right? Seems like this is the way to go. And now if I go into me, I hopefully should be able to include Lua. There it is. Awesome. And if I now, for example, build, can I build? Yes, I can. Hello, that's nice. Was we have to initialize Lua. Try it out. Wait, see. In main, paste it in here. That's not fun. This. How is this undefined? Quickly do this. Lua else state is undefined. What do you mean? Who is here? Lua.hpp? Is that what it needs? But yeah, it doesn't exist. Lua.h. What does Lua.h mean? Excuse me. Wait, let's go into no. Start, right? Let's go to learning, documentation. Yes. Okay, I'm not thinking straight. Let me just go and put the needs P. Let's add a there's audio, game, image, media. Bathroom. BRB. Go with the. Here we are. Listen. And I'm back. Right. Feeling refreshed. Okay. Here, this is what we're searching for, right? Yeah. I guess should work. Maybe. What? Example. Search for a working example. Learning. Yeah. Okay, give me a good example. Yeah, sure. Come on, give me a working minutes. Okay. That's weird. Didn't give me anything. This is also not what I'm looking for. Ew, is it? Is it because I have to do this? And this in here? Could that be? Hmm. Okay. The fact that it finds this, not that, gives me feeling that it's something maybe and like encourage or whatever. To do this, right? The issue is it doesn't find it, right? There's no such thing as lib. So my main. Okay, so generally what I would do is this, right? But here, CMake error. That's okay. Seems like getting it from getting the actual files from their own original GitHub. Like it's not the best idea. latest. It is 547. Awesome. And I do have to CMake this. Okay, this doesn't exist anymore. That. And okay, so and I don't have to do this. Probably. Okay. And if I do this, this is not. Okay, I'm getting. So I do get this right. Yeah, cool. This is a fine goal. Course. Right. Package. Okay. Yeah. This should work, right? Identifier is undefined. Lower HPP, that's what it tries. Hey. So if I build this, it should build. Like it does. Hey, okay, we built it. So if I run it now, I should get a hello from Lua. Hello to you too, dear Lua. Awesome. Okay, so we have Lua, right? Lua isn't here. That's quite the achievement. But then I'm gonna delete this. And our music is over. Let's put up some nice AI generated. Here. Close that. Dissolve. Alright, awesome. So that's done. So now we can go over to Soul, right? Soul seems to be a single header library. So let's see how we add that. For that, we are again going to need this. Right? Let's copy this over. Go to GitHub. Search for. And let's see. I think version 3.5.0. Not the latest. That is the latest. Interesting. I suppose 3.5.0 is not yet done. But okay. I do this, and then I go 3.3.0. Oh no, not Lua. Dang it. Soul 3, let's go. is enough. Might be, might also not be. Oh, my music has been very loud. Okay. Food all slash hold.hpp. Is that what he wants us to include? Yes. And then like this. Let's build. Holy, we've added coal. Okay, I'm impressed. That kinda wasn't hard. It makes sense to do this as well, right? What if we do this? That, but also, and if we build it, builds, cool. Okay. So that's nice. I can't move this because it's being set to the coordinates of the transform. Hey, how long have I been streaming? It's been an hour and 15. Than that, but this is very nice, actually. Okay. Excuse me. That was rude. let's read through the documentation together. Right here, it's nice too. I'll probably have to sneeze again. But, can we not make this dark mode? Seems like we can't, but okay. So, it says working with variables is easy with Sol. Yes, and behaves pretty much like any associative array map structure you might have dealt with previously. Let's say we have this Lua file that creates a table, right? Because if I'm correct, Lua has only one data structure, which is the table, which is any type of a map, like dictionary or whatever. So here we have a config map with a key saying full screen is false, resolution is, I guess that's another map, okay, with an X and a Y. Cool. What does this do? Includes tuple, assert, and utility. Why does it need there? Okay, it gets this boolean, bool, whole table config gets the whole table and thing. Not sure why tuple and utility were there, but okay. You can check if everything is good. Okay. So from this example, you can see that there's many ways to pull out once. Nice. For example, to determine if a nested variable exists or not, you can use auto to capture the value of lookup, and then use dot val. Yes. This comes in handy when you want to check if a nested variable exists. You can also check if a top level variable is present or not by using install optional, which also checks if A, the keys you're going into exist, and B, the type you're trying to get is of a specific type. Okay. Let's do this. So yes, initialize the Lua, open variables of Lua. And then from the state, try and find config this variable. Inside of that variable, find full screen. Okay. And the optional, as it said above, checks if it exists. In this case, yes, it does, right? Because the config had a full screen member key. But it does also check if it's an integer. In this case, it's not, so it does not take this branch. It's a boolean, yes it is, and it goes here, awesome. And then in here it does not exist, so also it doesn't go in here. I also get the get or methods. What is that? Ah. Hey, welcome. Yeah, let me just tell you what I did. I added Lua and Sol 2, so now I'm going through the actual documentation. Next step is like creating a system where game objects can read and yes, execute Lua scripts. So quite proud of that. So yeah, in here we were reading about yeah. I did run into some trouble with CMake though, so we did ask Geppetto for some help. But yeah, it was weirdly you like the original Lua development GitHub repository isn't really suited to add to your repository, like to your own CMake projects. So I found another one which nicely did. So it was like made specifically for modern CMake. So all I had to do was just fetch content, give it the git tag, the git repository link, and then in target include target link libraries, I just had to do like Lua : Lua, and bam, it's in there. So why am I not showing you this? Here, this. You go in here, right? This is the specific CMake branch, but you can't see that. Awesome. So this is like the specific CMake branch for Lua, handled by someone else, like a third-party person. All I have to do with this is here, this. I link the library, and I'm done. I can include Lua. So nice. Same thing with Soul, right? I just get it, and then I include it. Now we have here, I just copy pasted some code, like some example code from the documentation of Soul. And it works. You create the state, right? You initialize Lua, you open some libraries for Lua to use, give it a script. In this one, it says bark, bark, bark. Nice. And if I run project, here we have it, right? But more importantly, look at this. It says bark, bark, bark. Hoggers, right? Also here, this is how I test my transform component, which was, I am setting this test component's position, right? Every frame. And I have this button that changes its internal state. So the game engine is coming along. I can't render yet though, but that's later. Yeah. So now we're going through the documentation so that for next stream we can actually do some rendering related stuff, right? And then what we could do is have like a small 2D player controller written entirely at runtime. Yeah, at runtime with a sprite that animates all through Lua. But yeah, to be able to do that, we first have to go through and learn and do studying. So we're looking at how to like retrieve variables from Lua script at the moment. And yeah, it seems pretty straightforward. And this is how you write to it, I guess. it in the global table. Okay. What's a global table? Note that the syntax, yeah, will make that variable, but if you tunnel too deep without first creating a table, the Lua API will panic. You can also be lazy with reading/writing values. Bar key, yes, valid. Yeah. Okay, so this is a lookup, right? We look if Bark exists. It's a Barky doesn't yet, I guess. This doesn't work. You give it a value, and then it is valid. So I guess this line modifies the Lua script, and like you write to Lua, because this you can be lazy, right? So I guess this is like a reference to something inside of Lua's virtual machine, and then if you assign anything to it, it actually does it to Lua as well. Not sure. Yeah, exactly. That's what I thought as well. Okay, finally, it's possible to erase a reference / variable by setting it to null. Okay, yeah, so it was a reference. Nice catch. So you have you set it, cool. You have an optional, x will have a value, yes, okay. If x has no value as expected, what? No, return normally, right? What? Wait. What? Am I going crazy? Wait, you create a variable in Lua called Bark with the value of 50. You retrieve the same thing, right? Set it to x, which is both like the variable exists, yes, plus it's an integer type, so okay, it should retrieve it. And it says itself, x will have a value. And then in here, it should go in here because x this prints x has no value. Huh? Okay. Kind of weird. Exactly. That's the state I am in right now. Well, here it gets deleted, right? So you delete the reference. Cool. Now why? It's yeah, no. This is probably a typo, right? Because x has a value here for sure. Here it will not have a value because you set it to Lua null, right? The reference gets deleted. And yeah, when it's deleted, then you should have no value. Yeah, like that's, I don't know. Probably. So it's easy to see that there's a lot of options to do what you want here. Yes, okay. But these are just traditional numbers and strings. What if we want more power, more capabilities than what these limited types can offer us? Let's throw some functions in there, or C++ classes into the mix. Let's go with functions first. So, Soul can register all kinds of functions. Many are shown in the quick and dirty, but here we will discuss many of the additional ways you can register functions into a Soul wrapped Lua. Cool. Setting a new function. Give it a C++ function. You can drop it into Soul in several equivalent ways, working similar to how setting variables work. Cool. So you make a variable called myfunc, and you just give it my function. Okay. You have Lua set. Okay, and then you have set function. All right. And then this function is now accessible as myfunc in Lua scripts. And this is like a global variable that gets stored inside of Lua, which is the return type of that. So it gets executed. So this gets a value. Okay. Okay. But what about arguments? The same code works with all sorts of functions, from member function to variable pointers you have on a class, as well as lambdas. Oh, that's powerful. My class underscore func. That's the name you give it in Lua. Okay. And then you have to give it your function pointer, right? And then a class instance. You will call a function on the given class instance. Okay, cool. So, this, I guess this is how we would bind a C++ function to Lua, right? Yeah, I suppose what you'd have is like you'd define your API that you want to give to Lua in C++, right? You like the get transform, get component functions, right? And when you do that, you do this, you set the functions, or like in the constructor of the game object, you set all the functions in Lua. Then in Lua, you can call all the correct functions without having to do them twice, I suppose. Right? Without like, you wouldn't have to make like a get component copy inside of Lua because it's going to call the C++ version anyway. I feel like, I don't know. I have to test, but I'm very excited. So in here, we do not pass a class instance. Yes, the function will need you to pass an instance of my class to it. Okay. Let's think about this. So my class func2, is that called anywhere? Oh yeah, here. Oh yeah, all right. So if you give it a class function, it does store it, which is awesome. Right, you can do that, but to be able to use it, you have to give it the this pointer basically, right? So you store the instance, and then if you want to call this second function that you defined previously, you have to give it the this pointer as your first argument, And probably if you have like more things that you want to give this function, that you could as well, but okay. Member class function and member class variables will both be turned into functions when set in this manner. Okay. How do you make member class variables a function? No, I don't know. Oh, I guess yeah, it makes getters for them, I suppose. You can get intuitive variable with the obj.a is value access after this section. When you learn about user types to have. Okay. Another question a lot of people have is about function templates. Yes. Oh no. Hmm. Okay. I could work with this. Could I? I'm not sure. Get component function kinda. Could I give it like a base class? Right, get component and then component. And anytime I use a derived class, it would work. I'm not sure. But dang, okay, that templated functions are kind of iffy. Okay. Oh, all right. Huh. So we can make an overload function with this templated function if we. Oh, okay. So I have a bad idea. We can make a function, right? I'm not sure. I'd have to look into this, but what if we have a function that gives us a generated version of this? Like we'd have to use like a macro or whatever that looks through all of our includes, right? Our include folder, the components folder that I have here, right? Let me show you. Control B here. We have our components folder, right? So we could have a macro or whatever, like a preprocessor directive, or I don't know, some way of going into this and then finding all of the names of the classes that exist, and then creating a function that gives us, I guess, this list of all the possible overloads for like the add component and like the get component functions. And that way, like in Lua, you'd be able to do that without issue, right? uh, okay. There are two ways to get a function from Lua. One is with solve function, another one is a more advanced wrapper with solve protected function. Use them to retrieve callables from Lua and call the underlying function. Two ways. Function F, yes, that ends, cool. Get an immediate decall, right? Store it into a variable first, and then call. Makes sense. You can get anything that's callable in Lua, including C++ functions you bind using set functions or similar. The protected function behaves similarly to solve function but has a error handler variable you can set to a Lua function. This catches all errors and runs them through the error handling function. Okay. So function handler with a message, return handled as message, right? If a is less than 0, all error, right? Okay, so sol protect function f, we retrieve this function, right? Then we set the error handler, Lua handler, cool. Okay, so I guess error is like a built-in thing. Yes, sir. Good luck. Thanks for stopping by. It was nice seeing you. So, I guess yes, error is like a built-in keyword, like function or whatever, that's automatically going to call error handler, right? But yeah, probably there's like a set function template or whatever that you have to follow. Like you have to have like at least one message probably. All right. So if result is valid, right, exit result. No, it didn't. Okay. You can return multiple items to and from Lua using tuples, pair classes provided by C++. These enable you to also use sol types, return values. Yes, sir. Have a good night. To receive multiple returns, just ask for a tuple type from the result of a function's computation, or sol tie a bunch of pre-declared variables together and set the result equal to. Okay. You can also return multiple items yourself from C++ bound function. Here we're going to bind a C++ lambda into a Lua, right? So we have a lambda that returns all of these. Cool. Then here it's called store it into a tuple again. So we use sol objects to transport through any value. That can come from Lua. You can also use sol make object to create an object from some value. Okay. All right. So, can give it anything, right? Okay. Okay, so if A is int, B is int, you return okay, wait, this is C++ code, right? So okay. Kind of confused about this state, right? I guess you give it Lua's state, right? Call in Lua get results. So yeah, okay. I guess it doesn't show this state, right? You probably need like the reason probably we get the state is because the make object always requires that Lua reference or like the state of Lua to be able to make the object. All right. Okay. If you need a bit more information about functions, sure, C++ and Lua. Let's see. Using user-defined types is simple but slow. All right. If you don't call any member variables or functions, then you don't even have to register the user type at all. Just pass it through. But if you want variables and functions on your user type inside of Lua, you need to register it. I'm going to give a short example here that includes a bunch of information on how to work with things. Take this player struct in C++, right? Okay. So player, it's default constructed to have 3 ammo and 100. Cool. Void boost, void shoot. Yeah, these are all just basic functions, right? Cool, but we don't want to have to rewrite this with meta tables in Lua. We want to be part of Lua easily. Yes. The following is the Lua code that we'd like to have work properly. We create a new player with 2, right? That's going to have 2 ammo and 100 hit points. Okay. And local P2 shoots is P2 colon shoot. Okay. Asserts not P2 at 0. Okay. We set P1 HP. That one from 100 gets changed to 545. Yes. Get the variable through property unqualified getter. Okay. 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 All right. So this is what P2 is, right? Player with 0 ammo. So this is going to return false, right? Assert true. Okay. To do this, you bind things using the new user type and method shown below. These methods are on both table and state and view, but we're going to just use it on state. Right? The set a variable p2 of type player with 0 MO. And it's just setting it by calling the constructor, right? And setting it. Nice. Note that you can set a user data before you register a user type, and it will still carry the right meta table if you register it late. Okay. Install user type, player type. Okay, that's what's happening here, I guess, right? You set user data, right, before you register the user type. Okay. Lua new user type player. And then that's name for the new user type probably. Okay. And then you give it all of the constructors that it can have. Okay. And you give it, for example, a member function called shoot. Okay. Get or set the value using member variable syntax. Okay, so you can give it a property as well. But then you'd have to have your own get and set. Alright, sure. Read and write variable, right? Speed is a variable. Okay, that's probably, for most things you'd need this, right? Speed and write, get and set probably. But if you have like custom getters and setters, that's how you just combine them into one property in Lua, right? And then player type dot set bullets to a read only. All right, that's nice. And a script file, prelude script, and then player script. There's one more method used in the script that is not in C++ or even defined in C++ code, right? Called break. Even if a method does not exist in C++, you can add methods to the class table in Lua. Cool. A script should run fine now. You can observe and play around with values. Even more stuff you can do is script elsewhere, like initializer functions, private constructors, destructor support, static functions callable with name.myfunction, and overloaded member functions. You can even buy global variables, even by reference with ref with var. There's a lot to try out. Yes, there is. This is a powerful way to allow reuse of C++ code from Lua beyond just registering functions, and should get you on your way to having more complex classes and data structures. In case that you need more customization than just user types, however, you can customize Sol to behave more fit to your desires by using the desired customization and extension structure. You can check out this code and more complicated code at the examples directory. Okay. Ownership. That's gonna be interesting. Ownership is important when managing resources in C++. Sol has many ownership semantics, which are generally safe by default. Below are the rules. Object ownership. You can take a reference to something that exists in Lua by pulling out a sole reference or a sole object. Okay, that's the reference to something. All objects must be destroyed before the sole state is destroyed. Otherwise, you will end up with dangling references to the Lua state and things will explode in a horrible, terrible fashion. Uh-oh. This applies to more than just sole objects. All types derived from sole reference and sole object, sole table, sole user data, etc. must be cleaned up before the state goes out of scope. Okay. Sense. Pointer ownership. Sole will not take ownership of raw pointers. Raw pointers do not own anything. True. Sole will not delete raw pointers because they do not and are not supposed to own anything. Again, true. Use/return a unique pointer or shared pointer. That. So you have a sole state, right? You create a function that returns a raw pointer, a new raw pointer. Okay. And then you give it again a raw pointer. And then, yeah, okay. So, yeah. If you want something to own, probably, right? Okay. If you have something you know is going to last and you just want to give it to Lua as a reference, then it's fine too. So lambda, right, that returns a my type pointer, creates a static instance of type and returns a reference to that static global object instance. Yeah, okay, that's something you can do, I guess. Sole can detect null PTR, so if you happen to return it there, okay, wait, no. So if you happen to return it, there won't be any dangling because a sole Lua null will be pushed. But if you know it's null beforehand, please return a null pointer T or Lua null. Excuse me. So don't return null PTR. Well, don't return a null PTR of an actual type, I guess. Okay. Okay, adding our own types. Mm, okay, yeah, no, this is that's probably above my pay grade. This is like actually adding uh your own type support, right? You have your own object, your own class that you wanna have stall, like I guess almost natively support, right? Um, uh, yeah, okay. Okay. Mhm. Okay. Then we have more about errors. Uh, mm. Mhm. Okay. Port compilers and whatever. Yeah, all extras. Um, okay, so I kind of got an overview of what Soul is capable of. I do have to let this like, simmer a bit in my head, and I'll have to think about how I want to structure my code, uh, especially the how to do the about update loops and how to have multiple scripts, Lua scripts as like components, I guess, on um, a single game object. Because I think that would be nice, right? Um, but yeah, thank you very much for joining me this 2 hour and 10 minute stream almost. Uh, Again, it was such a nice stream. Um, got some things done with Lua, put that into the project. We got all into the project as well, allowing us to do things with Lua just a bit more natively, a bit more easier, intuitively. Um, and yeah, hey, uh, next time I think we'll probably have some sprites running around or screen. Uh, I guess something interesting that I want to do is probably um, have. Hmm. Yeah, no, I kind of want to make like the DVD screensaver thing with then with Lua, right? Um, I think that's the challenge for next stream. See you tomorrow. See you the day after that, maybe. And yeah, thanks for tuning in.